Today our topic is indices. Now, if you have a to the power n, now we call this is the exponent, and this we call it the base. And if you have a to the power n, this means that you have a times a times a times. It means that this a is multiplying itself, that is n times, or all that we are saying that this is what n factors. You are multiplying this a n times. So if you have a to the power 4, it means you have a times a times a times a. How many times? 4 times. If you have a to the power, let's say 3, this a times a times a, that is 3 times. And then also, if you have 2 to the power 5, that is 2 times 2 times 2 times 2 times 2, that is 5 times. 1, 2, 3, 4, 5. And if you have 1 over 3 all to the power 6, it means that you are multiplying this 6 times. So you have 1 over 3 times 1 over 3 times 1 over 3 times 1 over 3 times 1 over 3. 1, 2, 3, 4, 5. And then the last one times 1 over 3. There are a lot of rules that will guide us to be able to simplify questions like this. And then the first rule, let's consider the first rule. The first rule says if you have a to the power m times a to the power n, the first rule is saying that when the bases are the same and you are multiplying, you have to add the exponents. So here that would be a to the power m plus n. That's the first rule. Now let's consider the following example. Now the first one, we have y to the power 3 times y to the power 5. Now the law says that when the bases are the same and you're multiplying, add the exponent. So the base is y. So you add the exponent. So here, that'll be y3 plus 5. And this is y to the power 8. Now let's see the second one. We have r to the power 3 times r to the power 15 times r to the power 7. When the bases are the same, you're multiplying, you add the exponents. So here we have r3 plus 15 plus 7. And clearly 3 plus 15, that is 18 plus 7, that is 25. R to the power 25. Now let's see the third one. We have 4x squared y to the power 3 times 3xy to the power 2. So we have numerals in front of it. So there are 4 times 3. That is 4 and 3. Then x squared times x, that's this times this. Then times y cubed times y squared. Now this, the bases are the same, so this is just to the power 1. So 4 times 3, that is 12. Times x, this will be 2 plus 1, because x without any power, that is, the power is 1, so 2 plus 1. Times y, we have 3 plus 2. So that will be 12, x to the power 3, y to the power 5. 2 plus 1, that is 3. 3 plus 2, that is 5. Now let's see the fourth one. We have 2a squared b times 3a squared b. And actually 2 times 3. So we have 2 times 3a squared times another a squared, that this and this. And then you have b times b. 2 times 3, this is 6. Then here that will be a2 plus 2, b1 plus 1. Now 2 plus 2, that is 4, so you have 6a squared. And then b to the power 2, because 2 plus 2, this will give us 4. And then 1 plus 1, this is equal to 2. Now let's see the fifth one. We have 6p to the power 3 times 2p squared times 4p to the power 4 times 2p all to the power 5. Now let's see the numerals beneath starting. So we have 6, 2, 4, 2. That's 6 times 2 times 4 times 2. We have p squared times p to the power 4 times p to the power 5. Now 6 times 2, 12. 12 times 4, that is 48. 48 times 2, that is 96. Now you have p, 2 plus 4 plus 5. You are multiplying. The bases are the same, so we add the exponents. So here we have 96 p, 2 plus 4, that is 6, 6 plus 5, and this is 11. Now let's see the root 2. What is the root 2 saying? The root 2 is saying that anytime you are dividing and then the bases are the same, you subtract. So if you have a to the power m all over a to the power n. Now we are dividing, so here we see that a m minus n. Or it can be put in this way, that is a to the power m divided by e to the power n. So this is a m minus n. So anytime that we are dividing and then the bases are the same, we subtract the exponent. Now let's consider the following example. The first one, a to the power 5 divided by a to the power 2. So we have first one, a to the power 5 all over a to the power 2. Now this, we are dividing, the bases are the same. So what do? We subtract the exponent. So here we have a to the power 5 minus 2. And this is 5 minus 2, this is a to the power 3. Now let's see the second one, p to the power 7 all over p to the power 2. We are dividing, so here we subtract the exponent. We have p to the power 7 minus 2, and this is p to the power 5. Now let's see the third one. We have 8p6 all over 4p to the power 4. Now here, what can you say? 4 going to 1, 4 going to 8, that is 2 times. So we have 2p6 minus 4, that is 6 minus 4. That's what we have here. And this is 2p6 minus 4, that is 2. Now let's see the fourth question. 18p to the power 5 all over 3p to the power negative 2. Now 3 will go into F1, 3 will go into 18, that is 6 times. So we have 6p5. Now this will go there to subtract. So we have negative, we have negative 2. Now negative and negative, that will be positive. So you have 6p5 plus 2, and this is 6p to the power 7. Now let's see 5. 18x squared y to the power 6 all over 2x y to the power 2. Now let's see, 2 go here 1, 2 go here, that is 9, 18 times that is 9. So you have 9. Okay, let's see, x to the power 2, but here is 1. So 2 minus 1. Y to the power 6 minus 2. Because this is 6, this is 2. So minus. And this will give us 9x y to the power 4. 6 minus 2, that is 4. Now let's see, question 6, we have x to the power 5 times x to the power 3 all over x to the power 2. Now here, let's see, we are multiplying the exponents. What do? We add. So we have x to the power 5 plus 3 all over x to the power 2. Why are we adding? Because bases are the same, you are multiplying, you add. So this is, we have x to the power 8 all over x to the power 2. 5 plus 3, that is 8. And this is, that is x 8 minus 2. And this is x to the power 6, because 2 minus 8, 8 minus 2, this is giving us 6. Let's see question number 7. Clearly 4 go here 1, 4 go in 32. This will be, that is 8 times. So you have 8 kill 9 minus 3. Then here we have R4 minus 1. And this is 8 kill 9 minus 3, this is 6. And then R to the power 3, 4 minus 1. That is 3. Now let's see example 4. Won't simplify the following. The first one says that I, 5p cubed times 2p negative 5 all over 2p to the power 4. Now that's what we have over here. What do we know? Indices is telling us when you're multiplying, the bases are the same, we add the exponent. So clearly 5 times 2, we can simplify that one, which is 10. But then p, we have p to the power 3 plus, that's negative 5 all over p to the power 4. And this is the same as t, that is there are 10 here. 3 minus 5, that is giving us negative 2 all over p to the power 4. This can go on top, so we have 10p negative 2 minus 4. Why are we subtracting p to the power negative 4, p to the power 4? Because we are dividing, we subtract the exponent. So we have 10p negative 6. Now let's see the II. 3 to the power 7 times 3 to the power negative 2 all over 3. Now what is it telling us? It is telling us that when we are multiplying, bases are the same, we add the exponent. So clearly here we have 3 to the power 7 plus, that's negative 2 all over 3 to the power 1. Now we have 3, 7 minus 2, that is 5. And then we have 3 to the power 1. Now this will be 3, 5 minus 1. Why 5 minus 1? In that we are dividing, bases are the same, so you subtract the exponent. So we have 3 to the power 4. Now what is 3 to the power 4? It means that 3 times 3 times 3 times 3. And this is just 81. Now let's see question number 2. That is 30 over xy squared divided by 6x squared all over x squared y. Now we have to note that if you have a over b divided by c over d, this division to change to multiplication, and you reciprocate the second term, In the same way, this will be, that is 30 over xy squared times x squared y all over 6x squared. Why? Division will change to what? Multiplication and reciprocate the second term. Okay, let's see. Can you see the x squared is cancelling out? X squared. 6 will go into itself 1. 6 will go into 30. That is 5 times. Now let's see. We have this 2. This is 1. So what do you have? That is 5. Why? But because it's 2, this is 1. We have 1 minus 2 because we are dividing all over x. This is the same as 5 negative 1 all over x. Or we can rewrite this as, that is 5 over xy. Now why? There's a property which says that if you have a to the power negative n, it's the same as 1 all over an. So if you have 2 to the power negative n, it's the same as 1 over 2. If you have x to the power negative, it's the same as 1 over x. So y to the power negative 1 can come down and we can have this. Now let's see question 3. So the division here will change to multiplication. So you have 3x over 4y cubed times, then you have 20y squared all over 21x squared. Now let's see, 3 will go into 1, 3 will go into 21, that is 7. 4 will go in 1, 4 will go into 20, that is 5. Now what do we have? Clearly the numerator becomes 5xy squared. The denominator becomes, that is x squared y cubed. I wrote the x first before the y. Now, because we are dividing, the bases are the same, x, what do? We subtract. So here we have 5x, 1 minus 2, y to the power 2 minus 3. And this is 5x negative 1, y negative 1. Now, what do you have? Clearly, this can be written as 5 over xy. As I said, there's a property that if you have a to the power negative, and this is the same as 1 over an. So there's a property that I used over here. Now let's see this too. So this division here will change to multiplication. So we have 9a cubed b squared all over 2c to the power 4 times here becomes 4ac squared all over 3a squared b to the power 4. Now here, let's see, 3 can cancel 9 and then the 2 can also cancel the 4. So 2 go here 1, 2 go into 4, that is 2 times 3 will go into 1, 3 will go into 9, that is 3 times. Now what can we see? We have 3. Let's look at the numerator. Now we have a to the power 3, a to the power 1. So here we have a to the power 3 plus 1. We have b squared c to the power 2. All over. Now let's bring the a first. So a to the power 2, b to the power 4, and then we have c also to the power 4. And this is giving us 3a to the power 4 because 3 plus 1, 4. B to the power 2, C to the power 2. All over a to the power 2, b to the power 4, c to the power 4. Now what do you do? What do we know? We know that if your multiplying base are the same, what do? You subtract the exponent. So here, this is just 3a. This is the first one, 4 minus 2. And then the second one, b, 2 minus 4. And then the other one, c, 2 minus 4. And here we have 3a to the power 2. And this is b to the power negative 4, c to the power negative 2, 2 minus 4, that's negative 2, 2 minus 4, that's negative 2. And this can be written as 3a squared all over b squared c squared. Because we have used the property a to the power negative, which is 1 over a n. Now let's see rule 3. Now if you have, that is a to the power m all to the power n, here we say that you multiply the m and n, so you see m times n. Now, let's see, so if you have simplify the following. The first one, if you have t to the power 2, 3. Second, if you have m to the power 6, 1 over 2. And then this, if you have 7 to the power, let's suppose that 7 to the power 1 over 2, all to the power 4. Now, let's see how we'll be able to simplify this, applying the rule. So you have t to the power 2, all to the power 3. So here you see, we have to multiply the exponents. So that's 2 times 3, and this is t to the power 6. Now let's see the second one, m to the power 6, and this will be m to the power 6 times 1 over 2, and this is m to the power 3. Now, let's see, we have 7 1 over 2 all to the power 4. What do? We multiply the exponents. We have 7 1 over 2 times 4. This will be a 1, this will be a 2. So we have 7 to the power 2. What is 7 to the power 2? 7 times 7, this is 49. Now let's see rule 4. If you have a, b, all to the power n, this is equal to, this is a to the power n, b to the power n. Now, this in Russia, it means that the AB, all to the power n, this is being multiplied, that is n times, that is n factors. And this is having, that is n factors. And this is the same as when you take the A. When you take the A, only the A, this one, and then also when you take the B, and B, and B, all the way times B. Now this one is n times, we have a to the power n. And this B also n times b to the power n. So therefore we are saying that a, b, all to the power n is equal to a, n, b, n. Now let's see the first example. We have to simplify, that is, the first one, we have 2x all to the power 2. And from the root, this is just 2 squared x squared. And this is just 4x squared, because 2 squared is what? 4. That is a, b, all to the power n. This is a, n, b, n. Now let's see the second one. We have 2 root 5 all to the power 2. So here, the same way, that is 2 squared times root 5 all squared. Now this 2 is multiplying the root 5. So this is 4 times 5, because root 5 squared is 5. And 4 times 5, this is 20. Now let's see the third one. We have 3a squared bc to the power 3, or c to the power 2 all to the power 3. Now applying the rule, we have 3 to the power 3, a to the power 2 times 3, c to the power 2 times 3. And clearly here 3 times 3, this is giving us 27, a to the power 6, c to the power 6. Now this is the fourth question. We know that a, b, all to the power is a and here. So this is 2 to the power 4, x to the power 2, all to the power 4, y to the power 3, all to the power 4. Times this, we have 3 to the power 3, x to the power 2, all to the power 2, y to the power 3, all to the power 3. Now here, 4 to the power 2, that is 16. What do you have here? X to the power 8, y to the power 12, 3 times 4, times, that is, we have 27. Now, 2 times 3, that is x to the power 6, y, that is 3 times 3, which is 9. Now you have 16 times 27, so you have 16 times 27. Here we have x to the power 8, there's another x, so 6. Why 6? Because we are multiplying, so we add. Now y to the power 12 plus 9. Now what is 16 times 27? This is 4, 3, 2. And this is just x to the power 14. Y to the power, that is 21. 12 plus 9, that is 21. Okay, let's see this example. Simplify, that is 3a all to bracket square all over 7b divided by a to the power 3, 14b to the power 2. Now this is what we have. We know that if you have ab all to the power n, it is a to the power n, b to the power n. So if you have 3a all to the power 2, this is just 3 square a square all over 7b divided by a to the power 3, that is 14b squared. Now this is just 9a squared all over 7b divided by a3 all over 14b squared. Division will change to what? Multiplication. We have 9a squared all over 7b times 14b squared all over a to the power 3. Now 7 will go into this of 1, 7 will go into 14. That is 2 times. 2 times 9, this will give us 18. Let's see, we have a to the power 2, we have a to the power 3. So this can just be a 2 minus 3. And then here we have b to the power 2, b to the power minus 1. And this is equal to 18a negative 1, b negative 1. So now 2 minus 1 is positive 1. Now, with this, how can we write this? We know that if you have a to the power negative n is 1 over an. Therefore, our answer becomes 18, let's see, b all over a. We can leave it this way, or we can leave it that way. Now, let's see question number 2. We have 2 to the power 3 all to the power 2 times 2 to the power 3 all over 2 to the power negative 2 all to the power 2. Now with this, by applying the rule, that is a n all to the power n, this is a n n. So this would be a to the power 6y, 2 times 3, 6 times 2 to the power 3 all over. And this time that will be 2 to the power negative 4. Now when you multiply, what do? We add the exponent. You have 2, 6 plus 3 all over 2 negative 4. 6 plus 3 is 9. So you have 2 to the power 9 all over 2 to the power negative 4. Now we know that when you are dividing, base are the same. What do? We subtract. So this we are going to get 2 to the power 9 minus, but then that one is negative, so you have negative 4. We have 2 to the power 9 plus 4. And what is 9 plus 4? That is 13. The question says that we should give our answer in index form. And this one is in index form. Now let's see the rule 5. It says that if you have a over b all to the power n, this is the same as a n all over b n. This is what the rule 5 is saying. An example, let's say simplify following. 2 over 3 to the power 4. 3 over 4 to the power 5. And then we have square root of, that is 8 squared times 4n plus 1 all over 2 over 2n times 16. Now, the first one, we have 2 over 3 all to the power 4. And from the root, this is just 2 to the power 4, 3 to the power 4. Now, 2 to the power 4 is 16. 3 to the power 4 is 81. Now, let's see the second one. We have 3 over 4 all to the power 5. Now, this is just 3 to the power 5 all over 4 to the power 5. You have a, b, over b to the power n, a and b n over bn. So 3 to the power 5, this is 2, 4, 3, and then 4 to the power 5, that is 10, 24. Now let's see the third one. Now the third one, let's say if you have a to the power 2 times 4 to the power n plus 1 all over 2 to the power 2n times 16. Over here we can make all the bases the same for us to have a base of 2. So this is just square root. 8 is the same as 2 to the power 3. And then there's 2 outside times 4. We can change 4 to 2 to the power 2 n plus 1 all over 2 to the power 2n. And then you can change to 2 to the power, that is 4. 2 to the power 4 is the same as 16. Now this is equal to, we have 2 to the power 6 times 2 to the power 2 n plus 1 all over 2 to the power 2n plus 4. Why plus 4? Because when you are multiplying the exponent, the base are the same, so you can add the exponent. Now this is the same as 2 to the power 6 plus 2n plus 1 all over 2 to the power 2n plus 4. Now let's see, we are multiplying. So what can we do here? Now we can subtract, the base are the same. So this is just, we have square root, and then this is just 2 to the power 6 plus 2n plus 1 minus plus 2n plus 4. Why? Bases are the same, so we subtract the exponent. So this is just root of 2, 6 plus 2n plus 2 minus 2n minus 4 equal to, now 6 minus 4, this will give us, 6 plus 2, that is 8 minus 4, so this will give us 4. Now 2n minus 2n, it will go away, so this will cancel this. Now what do you have? What is 2 to the power 4? This is 16. And what is root 16? Root 16 is just 4. Now let's consider the following properties under indices. Now if you have any non-zero number to the power 0 is 1. So if you have 2 to the power 0, 1, negative 1 over 3 to the power 0, 1. If you have 1 million to the power 0, you have 1, 2, 3. That is 1. Any number at all to the power 0 is 1. And then also, if you have a to the power negative, and this is the same as 1 over an. If you have a, that is a to the power negative n. An example is, if you have 2 to the power negative 1, that is 1 over 2. If you have 3 to the power negative 1, 1 over 3. If you have x, y, all to the power negative, this is the same as 1 all over x, y. And then also, a reduction from this, if you have a over b all to the power negative n. Now, this is just the same as b over a, and then the negative will go away. What are you supposed to do? Just reciprocate, and when you reciprocate, the negative will go away. And this is the same as b to the power n, a to the power n. Now let's see. If you have a over b all to the power negative n, this is the same as a negative n all over b negative n. And then we know that if you have, that is, if you have a to the power negative n, this is the same as 1 over a negative positive n. We have, this can be written as a negative n times 1 over b negative n. Now this is the same as 1 over a to the power n. And this can go on top, and we have b to the power positive n. So this is the same as b to the power n all over a to the power n. This is the same as b over a all to the power n. And this b and for me we have b. Now fractional indices. So if you have a to the power 1 over n, this is just the same as, this can be written in this form, that is that. And then also if you have a to the power m over n, this can be written as, that is a, and this we can write this as m times 1 over n. This is the same as a to the power n, and this can be written in that form. Or you have a to the power m over n. This is the same as, that is a 1 over n, and then we have m here, the same root of a, and then what do you have? All to the power n, all to the power n. Now let's see if this example should evaluate the following. The first one, that is 16 all to the power 1 over 2, and it's the same as root 16, because 1 over 2, the square root, this is 1 over the same as square root of 16, and square root of 16 is the same as 4. Or if you have 16 to the power 1 over 2, now because if you have 1 over 2 here, 16, I can change 16 as 4 to the power, because 4 to the power 2 is the same as 16. So I have 4 to the power 2 times 1 over 2. This will cancel this, and this will give me 4. Now let's see the second one. We have 27 to the power 1 over 3. Now this is 1 over 3. 27, 3 to the power 3 will give us 27. So here we have 3 to the power 3 times 1 over 3. This will cancel this, and this will give us 3. Now let's see the third one. We have square root of 3. We have 27 x cubed y to the power 9. And cube root, this is the same as, so here we have 27 x to the power 3, y to the power 9, all to the power 1 over 3. Now from here, we know a, b, all to the power, we know that a, b, all to the power, and this is a, n, b, n. This implies that we are going to get, that is 27, 1 over 3, x to the power 3, then 1 over 3, y to the power 9, 1 over 3. This will cancel it. This will go 1. This will go here. That is 3 times. Now you can change this also to 3 to the power 3. So 3 to the power 3 times 1 over 3. X to the power 1. Y to the power. Y to the power 3. Now we have 3 x y to the power 3. Okay, let's consider this example. We should evaluate the following. The first one, we have 27 to the power 2 over 3. Now, because here it is 2 over 3, it means that this, we can change this as a number to the power 3. Now, twins, how can we change to a number to the power 3? This is the same as 3 to the power 3. Remember, we have 2 over 3 outside here. This is just 3 to the power 3 times 2 over 3. Now this will cancel this. You have 3 to the power 2. And then this is 9. Now let's see. We have 8 over 27 all to the power negative 2 over 3. Now, because we have negative 2 over 3, because this is negative, you knew that if you have a over b all to the power negative n, it becomes what? B over a all to the power positive n. So here you have to reciprocate. You have 2 over 27 all over 8, and then the negative will go, so we have 2 over 3. You have to reciprocate. As soon as you reciprocate, then the negative goes away. Now let's see, this is 2 over 3. So it means here, you change this to a number to the power 3, and then also to the power 3. And this is just the same as 3 to the power 3. This is also 2 to the power 3. And then we have 2 over 3. Now what do we know? If you have a over b all to the power, it's a n over b n. So this is just equal to 3 to the power 3 times 2 over 3 all over 2 to the power 3 times 2 over 3. Now this will cancel that, this will cancel that. 3 to the power 2, that is 9. 2 to the power 2, that is 4. And this is the same as 2 number 1 over 4. Now let's see the third one. We have 1 over 64 all to the power negative 5 over 6. Now this is what we have over here. Because it's negative, what are we supposed to do? Reciprocate. So we have 64 all over 1 all to the power 5 over 6. The negative go away. Now this is 5 over 6, and something to the power 6 should give us the 64. 2 to the power 6 is 64. So 2 to the power 6 times 5 over 6. This will cancel this. So we have 2 to the power 5 and 2 to the power 5. This is 32. Now let's see this example. That's 27 over 64 to the power negative 2 over 3. This is a past question. So let's see, we have 27 over 64 all to the power negative 2 over 3. Now, this negative, because of the negative value, we have to reciprocate what is in the bracket. So this will be 64 all over 27 and then 2 over 3. So the negative will go away. And this is the same as, you see, this is 2 over 3. So we have to change this to a number to the power 3. Change this to a number to the power 3. 4 to the power 3 is the same as 64. 3 to the power 3 is the same as 27. 2 over 3. Now, this is the same as 4 to the power 3 times 2 over 3 all over 4 to the power 3 times 2 over 3. Now, this will cancel this. This will cancel that. So we have 4 to the power 2, and then the down one, that is 3 to the power 2. 4 to the power 2 16. 3 to the power 2 is 9. How many times will 9 go into 16? That is 1. So 1, 7 all over 9. Now let's see question number 2. We have 32 to the power 2 over 5. Now this is 2 over 5. That is the exponent. So here we have to change the 32. So here, because it's 2 over 5, 2 over 5 here, and what number to the power 5 will give us 32? That is 2 to the power 5. So you have 2 to the power 5 times 2 over 5. Now this 5 will cancel this. We have 2 to the power 2. 2 to the power 2 is 4. Now let's see 3. We have 2, 1, 6 all to the power 2 over 3. Now 2, 1, 6. What value to the power 3 will give us 2, 1, 6? And clearly from here, the number to the power 3 clearly here, 6 to the power 3 will give us that. So we have 6 to the power 3 times 2 over 3. This will cancel this. We have 6 to the power 2, and this is giving us 36. Now let's see the fourth one. 16 over 81. We have b all to the power 8, and then we have 3 over 4. Now this is over 4. What can we do over here? Now 16 and then 81, because this is 3 over 4. 7 to the power 4, 7 to the power 4. So then we have 2 to the power 4, we have b to the power 8. All over 3 to the power 4. 3 to the power 4, you see, plus 81. We have 3 all over 4. And this is the same as, that is 2 to the power 4, b 8. All to the power 3 over 4. All over 3 to the power 4 times 3 over 4. Now this will cancel that. Now let's see the numerator. We have, that will be 2 to the power 4 times 3 over 4. We have d to the power 8 times 3 over 4. What do we know? We have ab all to the power n. This is an, bn. This one we know. Now this will cancel this. All over here, we have 3 to the power 3. Now let's see, 2 going to sub 1, 2 going to 8. That is 2 times. So what do you have? 2 to the power 3. 3 to the power 2 times 3, which is 6. All over 3 to the power 3. Okay, this will be, that is 8 over 27, d to the power 6. Now let's see the fifth one. We have 49 to the power 1 over 2 plus 125 to the power 1 over 3, all to the power 2. Now this, we have to simplify the bracket first. So you have 7 to the power 2 times 1 over 2 plus this 125 to the power 1 over 3. This is 5 to the power 3 times 1 over 3, all to the power 2. This will cancel this will cancel that. So we have 7 plus 5 all to the power 2. Bracket first, board mass. What is 7 plus 5? 7 plus 5 is 12, so you have 12 to the power 2. What is 12 to the power 2? This is 12 times 12. And this is 144. Okay. We are going to simplify the following. We have 1 over 3 to the power 5 n times 9 to the power n minus 1 times 27 to the power n plus 1. Okay, now that's the question over here. What can we see? We can see that we can make all the bases the same. So here, let's see, we have 1 over 3 to the power 5n. Now this, we can express this as 3 to the power 2, because 3 to the power 2 is the same as 9. Then times this 3 to the power 3, we have n plus 1. And because we are writing it in this way, because if you have a to the power n, and see that this is the same as a, n, and then m multiplies the n, and that is what we have. Now, we also know that a to the power negative n is same as 1 over a n. So this can be expressed as 3 to the power negative 5n times 3 to the power 2 n minus 1 times 3 to the power 3 n plus 1. Now, the bases are the same, your multiples. What do? We add the exponents. Here you have 3 to the power negative 5n times 3. And because it is multiplication, let's add. So plus 2, you have n minus 1 plus 3 n plus 1. And you have 3 negative 5n plus 2n minus 2 plus 3n plus 3. You have 3. Now, 2n plus 3, and that is 5n minus 5n, that will be 0. Negative 2n plus 3, that is 1. So our answer is 3. Now, let's see the second question. We have 2. This is a past one divided by 64 all over 125. And this is to the power negative 2 over 3. Now, bracket first, board mass. So let's do the bracket first. 2 divided by. Now this is negative. So what are you supposed to do? Reciprocate so that the negative goes away. And this 2 over 3, and because it's over 3, here it means that the number to the power 3 will give us 125, the number to 3 will give us 64. So you have 2 divided by, now here becomes 5 to the power 3, and 4 to the power 3. You have 2 over 3. Applying the power rule, that is 2 divided by, this would be 5 to the power 3 times 2 over 3, all over 4 to the power 3 times 2 over 3. This will cancel this, this will cancel this. So you have 2 divided by, you have 5 to the power 2, all over 4 to the power 2. And this is 2 divided by 25, and then 4 to the power 2, that is 16. Now division will change to multiplication. So we have 2 times 16 all over, that is 25. Now we know that every whole number is 1. So numerator times numerator, denominator times denominator. 2 times 16, that is 32. 1 times 25, we have 25. How many times do 25 go into 32? That is 1 times. And then what do you have here? This would be 7 all over 25. Now let's see this. 4 over 25 all to the power negative 1 over 2 times 2 to the power 4 divided by 15 over 2 all to the power negative 2. Now, because of the negative, what do we do? We reciprocate. So you have 25 over 4 all to the power positive 1 over 2 times 2 to the power 4 divided. This would be, that is 2 over 15 all to the power positive 2. What do you know? If you have a over b all to the power n is a and b n clearly, and because it is 1 over 2, this is the same as 5 to the power 2 all over 2 to the power 2. We have 1 over 2. Now this can be 2 to the power 4. This is the same as 16 divided by 4 all over 15 squared is 2 to 5. Now this is 5 to the power 2 times 1 over 2. 2 to the power 2 times 1 over 2 times 16 divided by 4 all over 2 to 5. This will cancel that. This will cancel that. So you have 5 over 2 times 16. Now division will change to multiplication into the reciprocal. So 2 to 5 all over 4. Now 4 will go into F1, 4 will go into 16 4 times. 2 go 1, 2 go 2. 5 times 2, we have 10 times 2 to 5. And this is 2 to 5, 0. Now let's see the fourth question. We have square root of 5 to the power negative 2 times 75 all to the power 1 over 2 times 12 to the power negative 1 over 2. Now, which of the properties are we supposed to use? You know, a to the power negative n is 1 over en. So this is just 1 over square root of 5 all to the power 2. Time this will be, we have 75, and then we can change it, but then you let's wait. So 75 all to the power 1 over 2. Now this is the same as 12 to the power 1 over 2. Now what can we see? This will cancel this with 1 over 5 times this. This will be, that is 25 times 3. 25 times 3 is giving us, that is root 75. Now this one is the same as root 4 times 3. Now we know that if you have root a, b, it is the same as root a times root b. So clearly from here, this will be 1 over 5 times, this will be root 25 times root 3 times 1 over root 4 times root 3. Applying that. Now this is 1 over 5. Root 25 is 5 times root 3 times 1 over 2 times root 3. Now what can you see? This 5 will cancel that 5. Root 3 will cancel root 3. So in the note we have 1 all over 2. Now let's say this is simplified negative into negative 1 over 27 all over negative 2 over 3. So what are you supposed to do? First, because of the negative, what do? We have to reciprocate it. So this will be negative. Now we have negative, because of the negative 2 over 3, as soon as we reciprocate, the negative is supposed to do what? Is to go away. So over here, this will be, that is negative 27 over 1. This will be 2 over 3. Now what do you have here? Negative, you have negative, but then we have 2 over 3. So something to the power 3. We know 3 to the power 3 will give us 2 over 3. So now let's see, we have negative. Let's see the inner one. We can let the 1 over 3 go inside. So we have negative 3 to the power 3 times 1 over 3 all to the power 2. Now this is cancelling this. So this will give us, that's negative 3 all to the power 2. This will be 9, so negative 9. And this will be our answer. Now let's see the second question. We are being told to simplify. That is x to the power 3, y to the power 5 all over x, y all to the power 7. In this base are the same, they're divided, so we subtract. So we have, this is just equal to, that is x to the power 3 minus 1 all over. Now why all over? This is 5, so I'll let it come here so that it will be, this is 5, this is 7, so this is greater than that. So I'll get y 7 minus 5. And this is x to the power 2 all over y to the power 2. And then this one, so this is the same as root x squared all over root y squared all over x over y. Let's see question 3. Find it in its simplest form, the product of this and that. So that's what I've written over here. We want to find the product of this. Clearly, what do? We take A, we multiply by the second term, that is the second bracket. We take B to the power 2 over 3, we multiply by the second bracket. So here we have A to the power 1 over 3, we multiply, we have A to the power 2 over 3. Then it's A1 over 3, B2 over 3, plus B4 over 3. Plus, now we take B to the power 2 over 3. What do you have? A2 over 3 minus A1 over 3, B2 over 3, plus B4 over 3. Now we are multiplying, base are the same, so we add the exponents. We have here A1 over 3 plus 2 over 3. But this time this, we have A 1 over 3 plus 1 over 3. Then we have B, that is 2 over 3. And then this one too, we have A 1 over 3, B 4 over 3. Now let's see this. We have A 2 over 3, B 2 over 3. And this time this, we have A 1 over 3, but the B 2 over 3 plus 2 over 3. 2 over 3 plus 2 over 3. And then this time this, that will be B 2 over 3 plus 4 over 3. Now, this is, we have 1 over 3 plus 2 over 3. And this is just 3 over 3, which will give us 1, so we have E. And there's this. Now, let's see this. This one is just the same as A 1 over 3 plus 1 over 3. This is just 2 over 3, B 2 over 3. Then here we have A 1 over 3, B 4 over 3. Then you have A 2 over 3, B 2 over 3. Now here, let's see, we have minus A 1 over 3, B 2 over 3 plus 2 over 3. This is the same as B 4 over 3. And then this one, that is 2 over 3 plus 4 over 3. This is 6 over 3, which is B to the power 2. Now, let's see, what can we see? Now, this and that are the same, so this will cancel that. Now, this one and that one, two are the same. So, what do you have? A plus B to the power 2, and be able to simplify it using indices. Solving exponential equation, we have two cases. Let's consider now the case one, the first case. If you have A to the power, that is n, equal to B to the power n. Here, because the exponents are the same, we say that implies that the basis are the same. So we say A is equal to B. And then the case 2 also says that if the bases are the same, then you equate the exponent. So if you have A to the power n equal to A to the power n. Here the bases are the same. So what do? We equate the exponents. We say n is equal to m. Let's consider examples under these cases. Now let's see this example. Solve for x in the following. First one, we have 3 to the power x equal to 9. And what can we do? We can make the bases the same. So you have 3 to the power x. Now 3 to the power 2 is the same as 9. Because the bases are the same, what do? We equate the exponents. So here x is equal to 2. Now let's see the second one. We have 2 to the power 3 times 2 to the power x equal to 2 to the power 7. Here we are multiplying. The left hand side we are multiplying. So because we are multiplying, the bases are the same, we add the exponent. So we have 2, 3 plus x equal to 2 to the power 7. Now here the bases are the same. So what do? We equate the exponent. You have 3 plus x equal to 7. X equal to 7 minus 3. So x is equal to 4. Now let's see question 3. We have 5 to the power x divided by 5 to the power 9 equal to 5 to the power negative 1. Because we are dividing the base at the same, what do? We subtract. So we have 5 to the power x minus 9 equal to 5 to the power negative 1. Now from here, what do? Base are the same. So what do? We equate the exponent. We have x minus 9 equal to negative 1. This has to be, we have x equal to negative 1 plus 9. And x is equal to, that is negative 1 plus 9. This is giving us, that is 8. Solve the following equation. The first one, x to the power 5 equal to 32. So the first one, we have x to the power 5 equal to 32. Now, here, we have the power to be 5. Here, we can also make the power to be 5. So here we have x to the power 5, and this, that will be 2 to the power 5 is 32. And because the exponents are the same, this implies the bases too are the same. So in a nutshell, if we have that is a to the power n equal to b to the power n, we are saying that a is equal to b, says what? The exponents are the same. Now let's see the second, we have x minus 1 to the power 3 equal to 64. Now here, clearly you can see x minus 1 to the power 3. Now here we can make the power also to be the same as 3. So you have x minus 1 to the power 3. Here it can be as, that is 4 to the power 3 is also giving us 64. And because the exponents are the same, we equate the bases equal to 4. So this one will come, we have x equal to 4 plus 1, and x is equal to 5. Now, let's see question number 3. We have 7 to the power x equal to 1. Now here, can we make the bases the same so that we equate the exponent? Yes. So you have 7 to the power x here. What do you have? 7 to the power 0, because 7 to the power 0 is 1. If this is 4 to the power x and here is 1, I can also change it for 4 to the power 0. So in this case, because the bases are the same, I can equate the exponent, say x equal to 0. Now let's see the fourth one. We have 2x plus 3 all to the power 5 equal to 125. Now this is to the power 3. Now here we can make the exponent the same. So here we have 2x plus 3. And here 5 to the power 3 is giving us 125. So clearly you have 2x plus 3 equal to 5. Why? The exponents are the same, so you equate the bases. Now over here, 2x can be equal to 5 minus 3. 2x, 5 minus 3 is giving us 2. And clearly, here we can find x by dividing both sides by 2. So 2x all over 2 equal to 2 over 2. This will cancel this will cancel that. So you have x to be equal to 1. And then also, if we have, let's say, 1 over 4 y minus 1 equal to 1, and we want to find y. Look at it. Here, 1 over 4. Here too, we can change this to what? 1 over 4, because if you have a to the power 0, it's 1. So because here the base is 1 over 4, here to I change to 1 over 4. So 1 over 4, y minus 1 equal to 1 over 4 to the power 0. Because the base are the same, we equate the exponent. Y minus 1 equals 0, y equal to 1. Now let's see this example. We solve for x in the following: a to the power x equal to 1 over 2. So the first one, we have a to the power x equal to 1 over 2. First, let's make all the bases the same. A to the power, this is the same as 2 to the power 3 x. But in this one, 1 over 2, it can be expressed as 2 to the power negative 1, because we know a to the power negative is equal to 1 over n. Clearly, the bases are the same, so we equate the exponent. 3x equal to negative 1. Therefore, x is negative 1 over 3. Now let's see the second one. 1 over 3 all to the power x equal to root of 3. Here, clearly, we can make the base the same. 1 over 3 can be written as 3 to the power negative 1 x equal to 3 to the power 1 over 2. Square root of 3 is the same as 1 over 2. Now, this This implies we have 3 to the power negative x, because negative 1 times negative x equal to 3 to the power 1 over 2. What can we do? We can equate this. We have negative x equal to 1 over 2. These are the same. We equate the exponents. We have x equal to negative 1 over 2. Let's see question 3. We have 4 to the power 2x minus 1 equal to root of 2. So then what can we do? We can make the basis the same. Here, 2 to the power 2 is the same as 4. And this is 2 to the power 1 over 2. The base are the same. What do? We equate the exponent. We have 2x minus 1 equal to 1 over 2. Let's expand. So that is 4x minus 2 equal to 1 over 2. Currently from here, the LCM is 2, so multiply each side by 2. It will be 8x minus 4 equal to 1, because 2 times 1 over 2 is the same as 1. This has to go there, so we have 8x equal to 1 plus 4. 8x equal to 5. So clearly our x is 5 over 8. Don't find x, so we divide both sides. Now let's see question number 4. We have 16 2x equal to 1 over 16. Now looking at this side, we can change this so that the basis will be the same. So you have 16 to the power 2x equal to 16 to the power negative 1. The basis, to make the base the same, you know a to the power negative n is 1 over an. Clearly the base are the same, so we equate the exponents. We have 2x equal to negative 1. So x is negative 1 over 2. We divide both sides by 2. Let's see this past question. We want to find x. We have to make all the bases the same. So here, there's nothing for us to do here. And then the 16, you can change 16 as 2 to the power 4. All over 2 to the power 1 minus x. And because we are dividing bases at the same, we subtract. We have 2 to the power 5x equal to 2 to the power 4 minus we have 1 minus x. We have 2 to the power 5x equal to 2 to the power 4 minus 1 plus x. Because this time this gives us that. So we have 2 to the power 5x equal to 2 to the power 3 plus x. Bases are the same, so we equate the exponents. So clearly from here, we have 5x equal to 3 plus x. 3 plus x. So this x will come here, and then, so we have 5x minus x equal to 3. 5x minus x, this is giving us 4x equal to 3. Our x equal to 3 over 4. Now let's see this example. We should solve the following. This is July 2009 question 1A. This one. This was an object 2009 question 1A. Now let's see the first one. We have 3 to the power 2x minus 1 equal to 9 to the power x. Here clearly we can make the bases the same. So 3 to the power 2x minus 1. This is 3 to the power 2. What do you have? Negative x. 3 to the power 2x minus 1 equal to 3 to the power negative 2x. Clearly the bases are the same, so you put the exponent. You have 2x minus 1 equal to negative 2x. This has to come and this has to go that you have 2x plus 2x equal to positive 1. Crossing positive. 4x equal to 1. Won't find x. Clearly, x is 1 over 4 because we divide both sides by 4. Now, let's see the second question. We have a to the power x plus 1 equal to 1 over 4. So we can make the base the same. You can change this to 2 to the power 3. You can change this to 2 to the power 2. So we have 2 to the power 3 x plus 1 equal to 1 over 2 to the power 2. Now this is the same as 2 to the power 3 x plus 1 equal to 2 to the power negative 2. The base are the same, so you put the exponent. So 3x plus 1 equal to negative 2. You can expand here. You have 3x plus 3 equal to negative 2. This has to go there. 3x equal to negative 2 minus 3. This is giving us negative 5. We want to find x, so this is negative 5 over 3. Now let's see question number 3. We have 4 to the power 2x minus 1 equal to 16 to the power negative 1 over 2x. Clearly, this is 4. We can change the base here also to 4. So we have 4, 2x minus 1 equal to 4 to the power 2. And what do you have? Negative 1 over 2x. Now, applying the power rule, that is a, m, n to equal to a, m, n, the 2 cancel that. So we have 4, 2x minus 1 equal to 4, 2 times negative 1 over 2x. This will cancel this. So we have 4, 2x minus 1 equal to 4 to the power negative x. What can we do? The base are the same. We create the exponents. We have 2x minus 1 equal to negative x. This has to go, this has to go there. 2x plus x equal to positive 1. 2x plus x, this is 3x equal to 1. X is 1 over 3. Now the question 4, which is the past question, 64 to the power n times 2 over 16 to the power 1 minus n equal to 4 to the power 2n. Because of these 2 here, it's better we change all the bases to 2. Now 2 times 4 will give us 64. 2 to the power 6 is the same as 64. You have 2 to the power 1 all over. This will be 2 to the power 4, 1 minus n equal to 2 to the power 2. What do you have? 2n over here. Now looking at this, we are multiplying. Bases are the same. What do? We add the exponents. We have 2. 6n plus 1 all over 2, 4, 1 minus n equal to 2 to the power 4n. 2 times 2, that's giving us 4n. Now the bases are the same. We are dividing. What do? We subtract. So we have 2, 6n plus 1 minus, that is 4, 1 minus n equal to 2 to the power 4n. The bases are the same, equal to sign. We equate the exponent. So clearly we have 6n plus 1 minus 4, 1 minus n equal to 4n. We have 6n plus 1 minus 4 plus 4n equal to 4n. We want to find n. Let's bring all the n's here. Let's take this to that side. So we have 6n plus 4n minus 4n equal to, we have negative 1 plus 4. Now, this will cancel this. We have 6n equal to 3. We want to find n. We divide both sides by 6. We cancel this. Will be 1, this will be 2. We have n to be equal to 1 over 2. This is also a past question. We have 1 over 2, so let's multiply each side by 2. So we have 2 times 1 over 2, 81n equal to 2 times 1 over 54. This will cancel this. This will be 1, this will be 27. 81 to the power n equal to 1 over 27. Clearly from here, we have 81 to the power n, we have 1 over 27. So clearly, what can we see? We can make the bases the same. So here, what do you have? 3 to the power 4. And well, 3 to the power 4 will give us 81 all over 1 over 3 to the power 3. 3 to the power 3 is the same as 27. Now we can change this. We know a to the power negative n is equal to 1 over n. So you have 3 to the power 4n equal to 3 to the power negative 3. Bases are the same. We equate the exponent. 4n equal to negative 3. We want to find n, divide both sides by 4. So our n will be equal to negative 3 all over 4. Now let's consider the following past question. Now 3n minus 1 all to the power 1 over 3 equal to 2. So the first one, 3n minus 1, 1 over 3 equal to 2. We want to find this n is in the radicals. What do? Because this is 1 over 3, we keep both sides. So we have 3n minus 1, we have 1 over 3, we keep both sides. So whatever we do to the left hand side, we have to do the same thing to the right hand side. So this will cancel this, 3n minus 1. Now this one is 8. So our 3n will be 8 plus 1. 3n is 9. We want to find n. What do? We divide both sides by 3. So our n is equal to 3. Now let's see question 2. We have 9 to the power 2x equal to 1 over 3, 27 all to the power x. First, let's make all the bases the same. Now this one will be 3 to the power 2. We have 2x outside. 1 over 3. 27 is the same as 3 to the power 3. We have x. Now, base are the same, we are dividing. We have to do what? Subtract. So from here, we have 3 to the power 4x equal to 3 to the power 3x minus 1. Why minus 1? Because, let's see over here. This one is 3 to the power 1. So 3x minus 1. And here, this will multiply this, we get 4x. So when the bases are the same, we equate the exponents. We have 4x equal to 3x minus 1. We want to find x, this has to come here. 4x minus 3x equal to negative 1. X is equal to negative 1. Now let's see question number 3. We have x to the power 5 equal to 10, 24. Now, clearly here, let's see. We have x to the power 5. 4 to the power 5 will give us 10, 24. Clearly, 4 to the power 5 is the same as 10, 20. 1024. Because the exponents are the same, we equate the base. So here, clearly, x is equal to 4. Now, question number 4 says that if you have 2 to the power x plus 2 times 8 to the power x equal to 1. Clearly, what are we supposed to do? Make all the bases the same. We have 2x plus 2. Here, 2 to the power will give us 8. 2 to the power 3 will give us 8. And it's going to multiply the x. Here, because we are making all the bases 2, this one will go 2 to the power 0. Now, clearly here we are multiplying. Bases are the same. So we add the exponent. So 2x plus 2 plus 3x equal to 2 to the power 0. Let's see. Bases are the same. We equate the exponents. We have x plus 2 plus 3x equal to 0. X plus 3x. 4x plus 2 equals 0. 4x equal to negative 2. So we have to divide both sides by 4. 4x over 4 equal to negative 2 over 4. So x is equal to negative 1 over 2. This will be a 1, this will be a 2. Now here, clearly we have 4 to the power 2 minus x times 16 to the power x plus 1 equal to 64. We can make all the bases the same. Let's make all the bases 4. We have 4, 2 minus x times here 4 to the power 2 is the same as 16. X plus 1. And then here 4 to the power 3. Bases are the same, we are multiplying, so we add the exponents. Plus 2x plus 1 equal to 4 to the power 3. The bases are the same, so what do we do? We equate the exponents. We have 2 minus x plus 2, x plus 1 equal to 3. Now this is 2 minus x plus 2, x plus 2 equal to 3. 2 plus 2 is giving us 4. Negative x plus 2x. This will give us x equal to 3. What do you do? Turn from here, x is equal to 3 minus 4. And our x is negative 1. So let's see, we can see that bases are the same. These bases are the same. But here, we can change this 8 to 2 to the power 3. Now because bases are the same, we are multiplying. This is just the same as 2, 1 minus y plus y minus y. Because we are multiplying, bases are the same. All over 2y plus 2. This is 2 to the power 3, 2 minus 3y. Now, this and this will cancel. This and this will also cancel. So we have 2 to the power 0. All over 2 to the power y plus 2 equal to 2 to the power 3, 2 minus 3y. These are the same. We are divided. So what do? You subtract the exponents. You have 2. 0 minus, we have y plus 2 equal to 2 to the power 3, 2 minus 3y. Base are the same. So we equate the exponents. We have negative y plus 2 equal to 3, 2 minus 3, 5. Clearly from here, what can we do? We have to expand. We have negative y minus 2 equal to 6 minus 9y. This and this and this, we have this. This has to go here, this has to come here. We have negative y plus 9y equal to 6 plus 2. This is moving here, positive. Now this is 8y equal to 8. I want to find y, divide both sides by 8. This is cancelling out there. This is cancelling 1. You have y to be equal to 1. Okay, let's solve the following example. The first one, 3 times 9 to the 1 plus x equal to 2 to the power 27 to the power negative x. So let's see. Now we have to make all the bases the same. So you have 3, but that's 3 to the power 1 times 3 to the power 2, that is 9. 1 plus x equal to 3 to the power 3, we have negative x. Now, because we are multiplying, we have to add the exponent. So 3, 1 plus 2, 1 plus x equal to 3 to the power negative 3x. Bases are the same, we equate the exponent. So 1 plus 2, 1 plus x equal to negative 3x. Now let's expand your 1 plus 2 plus 2x equal to negative 3x. We want to find x. Now what is it? This 3 plus 2x equal to negative 3x. This has to come here, this has to go there. 2x plus 3x equal to negative 3. 2x plus 3, this is 5x equal to negative 3. Dividing both sides by x, we have x to be equal to negative 3 all over 5. Now let's see the second one. We have 9 to the power 2x plus 1 equal to 81x minus 2 all over 3 to the power x. What are we supposed to do? Make all the bases the same. So here, that's 3 to the power 2, that's the 9. 2x plus 1 equal to 3 to the power 4x minus 2 all over 3 to the power x. Now, there's a problem here, so you have 3, now we can expand the numerator, the exponent, you have 4x plus 2, this time that, equal to 3, 4x minus 2 minus x. These are the same, we equate the exponent, so clearly we have 4x plus 2 equal to 4x minus 2 minus x. Let's expand this, 4x minus 8 minus x, we have 4x plus 2. Now, let's see, we have 4x minus x. Let's bring everything here. We have 4x minus 4x plus x equal to negative 8. This will be there, minus 2. Now, 5 minus 8 will go away, x. We have x, negative 8 minus 2. This is negative 10. Clearly, what can we do? Make all the bases the same. Or here we can even cross multiply. So we have 9. 2x minus 3 equal to 3x plus 3. So you can make the base the same. So you have 3 to the power 2, 2x minus 3 equal to 3 to the power x plus 3. Now base are the same, so you equate the exponent. 2x minus 3 equal to x plus 3. Now what we have 2 times this, 4x minus 6 equal to x plus 3. Now this has to come in, this also has to go there. So 4x minus x equal to 3 plus 6. 3x equal to 9. I want to find x. Divide both sides by 3. Clearly my x is equal to, that's 3, because 3 will go into 9 3 times. Now let's see the fourth one. We have 1 over 81 x minus 2 equal to 371 minus x. You have to make all the bases the same. Now this becomes 1 over 3 to the power 4 x minus 2 equal to 3 to the power 3 1 minus x. Now we know that if you have a to the power negative n, it's the same as 1 over en. So if you have this, you can see this. So this one is the same as 3 to the power negative 4 x minus 2 equal to 3 to the power 3 1 minus x. Bases are the same. We equate the exponent. Negative 4 x minus 2 equal to 3 1 minus x. We can expand. So we have negative 4x plus 8 equal to 3 minus 3x. We group like them. This has to go there. This has to come in. So negative 4x plus 3x equal to 3 minus 8. Now this one will give us x. And then 3 minus 8, this is the same as negative 5. Let's consider this example. That is 8 into bracket 2 to the power x plus 1 equal to 2 square root of 2 to the power x. So the first one, we have 8. 2x plus 1, 2 root of 2 to the power x. Now this is 8, and this 8, we can change this 8 to have the same base as the 2 over here. So we can change the 8 to 2 to the power 3. Times, this will be 2, the same thing, x plus 1, 2. Now 2, that is 2 times, this is 2 to the power x, all to the power 1 over 2. Now what is happening over, because we are multiplying, bases are the same, we add the exponent. So in a nutshell, you can get 2 to the power 3 plus x plus 1 equal to 2 to the power 1 times 2, and this would be just x over 2. Now this one would be 2 to the power 3 plus 1, so we have 4 plus x equal to 2 to the power 1 plus x over 2. Because the bases are the same, we have an equal to sign here, we equate the exponents. We have 4 plus x equal to 1 plus x all over 2. From here, the LCM is 2, multiplied by 2. That's 2 times 4, 2 times x, 2 times 1, plus 2 times x over 2. This will cancel that. Now we have 8 plus 2x equal to 2 plus x. We group like terms to find x. So the x will come here, you have 2x minus x. This is coming here. Now we have 2 here, 8 is going there, so that will be minus 2 minus 8. Now 2x minus x, this is x, and this is negative 6. That's the first one. Now let's also see the second question. The second question is 2 to the power x squared minus 24 equal to 16 to the power x. Here, what should we do? We have to make the bases the same. So this is 2, this is 16. Now 16 can be changed to 2 to the power 4. So that is 2 to the power 4, and it's going to multiply the x. Now bases are equal, so you equate the exponent. So you have x squared minus 24 equal to 4x. So this has to come here. So you have x squared minus 4x minus 24 equal to 0. Two numbers, when you multiply, you get negative 24. When you add, you get negative 4. That is negative 6x and positive 2. Negative 6 and positive 4. Now, this is what is common. X is common. So we have x minus 6 plus 4, x minus 6 equals 0. X minus 6 is common. X minus 6 is common. Factorize out. What do you have here? X plus 4 equal to 0. So you have x minus 6 equal to 0, or x plus 4 equals 0. X is equal to 6, or x equal to negative 4. Now let's see the third question as well. We have 2 to the power x squared minus 5x equal to 1 over 64. We have to make the LCM the same. So you have 2 to the power x squared minus 5x equal to, this is the same as 1 over 2 to the power 6. Now you have 2 to the power x squared minus 5x equal to 2 to the power negative 6. Bases are the same, we equate the exponent. We have x squared minus 5x equal to negative 6. We are getting a quadratic equation. So that is x squared minus 5x plus 6 equals 0. Why plus 6? Negative crossing becoming positive. Now 2 numbers in the multiply, you get 6. When you add, you get negative 5. That's negative 2, negative 3. You have x squared minus 2x minus 3x plus 6 equal to 0. This to what is common? X is common, so you have x minus 2 minus 3, you have x minus 2 equals 0. X minus 2 is common. We bring it out. What is left here? X minus 3 equal to 0. Two numbers multiply equal to 0. So you have x minus 2 equal to 0, or x minus 3 equal to 0. clearly we have x equal to 2 or x equal to positive 3. Now let's see this example. Solve the following. The first one, 16 to the power n equal to cube root of 2 to the power 2. This is May, June 2018, question number 6e. Now that's it. What are you supposed to do first? Make all the bases the same. You can change this to, that is this, okay. This, we can change this as 4 to the power 2n. And this cube root is the same as, what do you have here? 2 to the power 2, so that is 4. And what do you have? Cube root, which is 1 over 3. Now this can be expressed as 4 2n equal to 4 to the power 1 over 3. Why this one change to this? We know if you have a, m, and this is a, m, and the m multiplies the n. From here we can equate the exponents. So we have 2n equal to 1 over 3. What's the LCM? LCM is 3. 3 times 2n, 3 times 1 over 3. This is cancelling that. So you have 6n equal to 1, n equal to 6. We want to find n, so we divide both sides by 6, so which is 1 over 6. Now let's see the second one. We have 1 over 3 to the power x times 9 to the power 3 over 3 whole number, 1 over 2, all over 3 equal to 27 to the power 2 over 3. Now here we can make all the bases the same. Now how can you change this? We know a to the power negative n is the same as 1 over n. So this is the same as 3 to the power negative 1 or x times this one is 3 to the power 2, and this can be 2 times 3, 6 plus 1, 7, so we have 7 over 2 all over 3 equal to, we can change this to be, that is 3 to the power 3, and we have outside 2 over 3. Now we know a, if you have, that is a, m, all to the power n, this is a, m, n. So you multiply, you have 3 to the power negative x times 3 to the power, these two will cancel these two, so you have 7 all over 3 equal to, this one will be 3, this will be 3 times 2 over 3, the 3 will cancel this, so 3 to the power 2, because this 3 will cancel this, leaving the 2 over there. Now we are multiplying, so what do? We add the exponent, that is the numerator. So we have 3 negative x plus 7 all over 3 equal to 3 to the power 2. Now this one will be 3 to the power negative x plus 7 minus 1 equal to 3 to the power 2. Now we are subtracting because we are dividing bases are the same. We can equate the exponents. We have negative x plus 7 minus 1 equal to 2. Now this has to go there, but then we have negative x plus 6 equal to 2, 7 minus 1. We have negative x equal to 2 minus 6. Negative x equal to negative 4. 2 minus 6, that's negative 4. We can divide through by the negative, so we have x to be equal to positive 4. Now let's consider question 3, that is 3 to the power x plus 3 to the power x plus 1 equal to 36. Now this is not multiplication, this is addition. Now from the rules of indices, which one can we apply here? We can apply the first rule. The first rule says that if you have a to the power m times a to the power n, this is equal to a m plus n. So it means that this is just the same as that. So you can break it down like this. So we have 3 to the power x, 3 to the power x plus 1 equal to 36. We'll start from this. We have 3 to the power x plus 3 to the power x times 3 to the power 1 equal to 36. Now 3 to the power x, 3 to the power x is common, so we can factorize it out. So we have 3 to the power x, what's left? 1 plus 3 to the power 1 equal to 36. What is 1 plus 3? 4. We have 4 times 3 to the power x equal to 36. Now this multiplies, so we can divide through by 4. So when you divide through by 4, we have 4 times 3 to the power x all over 4, 36 all over 4. This is cancelling out that. So we have 3 to the power x equal to 9. 4 going here, 1, 4 going 36, 9 times. We can make the base the same. So you have 3 to the power x equal to 3 to the power 2. Bases are the same. We can equate the exponents. We have x equal to 2. Now let's see question number 4. The fourth one says that you have 2 to the power x plus 2 to the power x minus 1 equal to 48. Now we can apply the first rule on this. So this is 2 to the power x plus 2 to the power x times 2 to the power negative 1 equal to 48. Now from here, what is common? 2 to the power x is common, so you can factorize it out. So you have 2 to the power x. What is left? 1 plus 2 to the power negative 1 equal to 48. Now, this is the same as 2 to the power x. This is 1 plus 1 over 2. 48. What is 1 plus 1 over 2? We can change this as 2 over 2, which should be 3 over 2. So we have 2 to the power x times 3 over 2 equal to 48. We can multiply through by the LCM, which is 2. So here we have, it is the same as 2 times 2 to the power x times 3 over 2 equal to 2 times 48. This will cancel that. So we have 2 to the power x times 3 equal to 2 times 48. We can divide through by 3. What is multiplying this? So we have 2 to the power x times 3 all over 3 equal to 2 times 48 all over 3. This will go here 1, this will go here 16. This and this will cancel. So we have 2 to the power x equal to 2 times 16, which is 32. We can make the bases the same. 2 to the power x equal to 2 to the power 5. 2 to the power 5 will give us 32. And this implies x is equal to 5. Equate the exponent, x equal to 5. Now let's see this example as well. Solve the following: 2 to the power 2y plus 2 minus 9 into 2 to the power y equal to negative 2. So that is what we have here. And clearly, let's bring this to here and equal to 0. We can see this can be transformed into a quadratic equation. So you have 2 to the power 2y plus 2 minus 9 into bracket 2 to the power y plus 2 equals 0. Using the first rule, we can break this one down. We have 2 to the power 2y times 2 to the power 2 minus 9 to bracket 2 to the power y plus 2 equals 0. We can say 2 to the power here, 2 to the power y here. We can also change this one to 2 to the power y, but this can change to 4. So this implies that is 4, 2 to the power y, all to the power 2, minus 9, 2 to the power y, plus 2 equal to 0. Now, clearly, we have 2 to the power by it is square, so this is in the form of a quadratic equation. So you can say let a be equal to 2 to the power y. This implies that we have 4a squared, because this is a, minus 9a plus 2 equal to 0. Now, this is a quadratic equation, which of the second case. So 4 times 2, which is 8. 2 now, when you multiply, you get 8. When you add, you get negative 9. Clearly, negative 8 and then negative 1. So you have 4a squared minus 8a minus a plus 2 equals 0. What is common here? 4a is common. You have a minus 2 minus 1a minus 2 equals 0. A minus 2, a minus 2, a minus 2. 4a minus 1 equal to 0. You are multiplying two things equals 0, so we have a minus 2 equals 0, or 4a minus 1 equal to 0. A equal to 2, or 4a equal to 1, a equal to 1 over 4. Now, what do you have? We know that that is 2 to the power y is a. So when our a is 2, that's when a is the first one, what are we going to get? We get 2 to the power y equal to 2. But this is to the power 1, therefore y is 1. And also when a is 1 over 4, we have 2 to the power y equal to 1 over 4. We can change the basis to be the same. 2 to the power y equal to 1 over 2 to the power 2. 2 to the power y equal to 2 to the power negative 2. Y equal to negative 2. Now let's say this example, question number 2. 2 to the power 2x plus 2 minus 5 divided by 2 to the power x plus 1. Now 2 to the power x is here. We can also get 2 to the power x also over here. Let's apply the first rule over here. So we have 2 to the power 2x times 2 to the power 2. And this will transform to this. Minus 5. We have 2 to the power x plus 1 equal to 0. Now 2 to the power 2 is 4. So you have 4 here. This can be changed to be 2 to the power x or to the power 2. Because this can multiply this and we can get this. So minus 5, you have 2 to the power x plus 1 equal to 0. 2 to the power x, we can let it to be a. So you can say that let 2 to the power x be equal to a. This implies that what do you have? You have 4a squared minus 5a plus 1 equal to 0. Multiply 4 by the constants. We have 4. 2 numbers, when you multiply, you get 4. When you add, you get negative 5. So this is negative 4 and a negative 1. So 4a squared minus 4a minus a plus 1 equal to 0. What is common? 4a is common. So you have a minus 1. Minus 1, you have a minus 1 equal to 0. A minus 1, 4a minus 1 equal to 0. So multiplying two things equals 0, you have a minus 1 equal to 0, or 4a minus 1 equal to 0. A equal to 1, or 4a equal to 1. Here a is 1 over 4. But what do we know? We know that 2 to the power x is equal to a. So when a is 1, what do you have? 2 to the power x, 2 to the power x equal to 1, equal to 1. Now here, we have to make the basis the same. This is 2 to the power x, and here, definitely, the base should be 2. So 2 to the power what will give us 1. 2 to the power 0 is 1, because any non-zero number to the power 0 is 1. So you have 2 to the power x equal to 2 to the power 0. This implies x is equal to 0. And then also, when a is 1 over 4, so you have 2 to the power x equal to 1 over 4. 2 to the power x, this can be changed as 1 all over 2 to the power 2. And we have 2 to the power x, and this is the same as 2 to the power negative 2. Why? A to the power negative n is 1 over a n. Clearly, the bases are the same. You can increase the exponents. We have x to be equal to negative 2. Now let's see the third one. We have 2 to the power x plus 32 into bracket 2 to the power negative x minus 12 equal to 0. We can see 2 to the power negative x here. We know that if you have, that is a to the power negative, and this is the same as 1 over a n. So let's apply this over here. So this implies we have 2 to the power x plus 32 all over 2 to the power x minus 12 equal to 0. We have 2 to the power x, 2 to the power x. We can say that let 2 to the power x be a variable. We can choose a. So you can say let 2 to the power x be equal to a. This implies that a plus 32 over a minus 12 equal to 0. LCM is a. We can multiply through by a. So you have a times a plus a times 32 minus 12 times a equals 0. This will give us a squared, but this is over a. So this will cancel that. Plus 32 minus 12a equal to 0. So you have a squared minus 12a plus 32 equal to 0. Two numbers, when you multiply, you get, that is 32. When you add, you get negative 12. This is clearly negative 8, negative 4. So you have a squared minus 4a minus 8a plus 32 equal to 0. What is common? A is common, so you have a minus 4 minus 8a minus 4 equal to 0. A minus 4, a minus 8 equal to 0. Multiplying two things equals 0, so we have a minus 4 equals 0 or a minus 8 equals 0. Clearly a is equal to 4 or a is equal to 8. But then what do we know? We know 2 to the power x is a. We know that, but 2 to the power x was equal to a. So when a is 4, so you have 2 to the power x equal to 4. We have to make the bases the same. So 2 to the power x equal to 2 to the power 2. Clearly x is 2. And then the other one too, that is when a is 8. So we have 2 to the power x equal to 8. When the bases, here we have to make the bases the same. 2 to the power x equal to 2 to the power 3. 2 to the power 3 will give us 8. We can equate the exponent, x is equal to 3. Now, this is an example under simultaneous equation, but it is still under indices. Let's see how such questions are solved. All these are past questions. Solve for x and y in the following equations. The first one, 2 to the power x plus 4y equal to 1. And then we have the other one, 2 to the power x plus 8y equal to 1 over 4. Now the first one, this is what we have. And in this, we have to make the bases the same. This one we have 1. So for us to make the base the same, we can change this one to 2 to the power 0. So we have 2 to the power x plus 4y. That is equal to 2 to the power 0. 2 to the power 0 is 1. Clearly, what do we have? X plus 4y equals 0. We can say this is equation 1. Now let's see the second equation. That is 2 to the power x plus 8y equal to 1 over 4. We can make the bases the same here. So 2 to the power x plus 8y equal to, this is 1 over 2 to the power positive 2. The bases are done the same here. So here we have to apply the other rule, which says that a to the power negative n is equal to 1 over an. So here we have 2 to the power x plus 8y equal to 2 to the power negative 2. Why? We know if you have a to the power negative is the same as 1 over an. From here we can equate the exponents. We have x plus 8y equal to negative 2. Let's call this equation 2. Now there's x here, there's x here. Clearly we can use the elimination method. So we can say that equation 2 minus equation 1. So x minus x is giving us 0. 8y minus 4y. This is giving us, that is 4y equal to, now negative 2 minus 0, that is negative 2. We want to find y, so we can divide both sides by 4. So we have 4y over 4 equal to negative 2 over 4. This is cancelling out that. We have 1, and then we have y equal to negative 1 over 2. We want to find x, so let's put, we can say that put y equal to negative 1 over 2 into any of them, so we can say into equation 1. What is equation 1? Which is this? We have x plus 4. What is y? Negative 1 over 2 equal to 0. This will be 1, this will be 2. So x minus 2 equal to 0. S equal to positive 2. This will go there. So we are going to get that. Now let's see the second one. If 3 to the power m times 3 to the power n equal to 243 and 3 to the power m divided by 3 to the power 2n equal to 9. So write down two equations connecting m and n. Hence, we should find the values of m and n. So the first one, this is what we have. Here, clearly, we can make the bases the same. So you have 3 to the power m times 3 to the power n. This is the same as 3 to the power 5. You can use our calculator to check. We are multiplying, bases are the same. We add the exponent, 3m plus n equal to 3 to the power 5. We have 3 to the power m plus n equal to 3 to the power 5. We equate the exponents. We have m plus n equal to 5. And this is equation 1. Now let's see the second equation. 3 to the power m divided by 3 to the power 2n equal to 9. Now with this, the bases are the same. So what do? Here we have 3, but here 2 is not 3, so let's make this to have a base of 3. 3m divided by 3 to the power 2n, and this is 3 to the power 2, which is 9. Now, let's see, we are dividing, and because we are dividing, what do? We subtract the exponent. We have 3m minus 2n equal to 3 to the power 2. Which principle did we use? We used the second rule, which is if you are dividing, these are the same, you subtract the exponent. Clearly, we can equate the exponents. We have m minus 2n equal to 2. Equation 2. Now, this is equation 1. This is equation 2. What we can use either the substitution or we can use the elimination. Let's use the substitution method. That is equation 2 minus equation 1. So we can say that equation 2 minus equation 1. Now, m minus m, that is 0. Negative 2n minus this, and that is negative 3n equal to 2 minus 5, that is negative 3. We want to find n, we divide both sides by negative 3. So you have negative 3 and all over negative 3 equal to negative 3 all over negative 3. N is equal to 1. So we can say that put or substitute n equal to 1 into any of them, we can say equation 1. Now, we know equation 1 is there, so n is 1 equal to 5. We want to find m. So we have m to be 5 minus 1. M is 4. Now the third one, if 9 to the power x times 3 to the power 2 equal to 1 over 7 to 9, and then 2 to the power negative x times 4 to the power negative y equal to 1 over 8, we should find the values of x and y. Okay, now from the first one, that is the first equation, we have 9 to the power x times 3 to the power 2y equal to 1 over 7 to 9. We have to make the bases the same. We can change this to 3 to the power 2. So we have x times 3 to the power 2y equal to 1. Now 3 to the power what will give us 7 to 9. That is 3 to the power 6. Now, because we are multiplying here, we add the exponents. We have 3 to the power 2x plus 2y. Y we are multiplying equal to 3 to the power negative 6. Y, if we have a to the power negative n, is the same as 1 over an. Now, base are the same. What did we equate the exponents? We have 2x plus 2y equal to negative 6. 2 is a factor of all of them. You can divide through by 2. So you have x plus y equal to negative 3. Let's call this equation 1. Now the second one, we have 2 to the power negative x times 4 to the power negative y equal to 1 over 8. We have to make all the bases the same. So you have 2 to the power negative x times, this will be 2 to the power negative 2y. Why? The 2 will multiply the y equal to 1 over 2 to the power 3. Now we know a to the power negative n is 1 over an. We apply it over here. So we have 2 to the power negative x times 2 to the power negative 2y equal to 2 to the power negative 3, applying the rule over here. Now we are multiplying, bases are the same, we add the exponent. So we have 2 to the power negative x minus 2y equal to 2 to the power negative 3. Bases are the same, we equate the exponents. We have negative x minus 2y equal to negative 3. Negative running through, we can divide through by the negative, so we have x plus 2y equal to 3. And let's call this equation 2. Now, what is equation 1? This is equation 1. This equation 2. Clearly, we can use elimination method, so we can subtract. So we can say that equation 2 minus equation 1. Now, x minus x is 0. 2y minus y is y. And then 3 minus 3, that will be 6. So we have our y to be equal to 6. So we can also say that put y equal to 6 into any of the equations so that you can get x. Let's say into equation 2. So you have x plus 2. What is y? 6 equal to 3. 2 times 6 is 12. X plus 12 equals 3. And then here clearly you won't find x. So x equal to 3 minus 12. Our x is equal to, that is negative 9. Now let's see the fourth one. This is also a past question. This is November 2019. If 3 to the power x times 9 to the power y equal to 243, and 3 to the power x divided by 3 to the power 2y equal to 1 over 27, the reason we should find that is x plus y. Now this is the first equation, so you have to make all the bases the same. So you have 3 to the power x times, this is 3 to the power 2y equal to 3 to the power 5. Now you apply this rule, right? That is, you have a m all to the power, you said a m n. This is the rule that we use. Now we are multiplying, these are the same, so what do? We add the exponents. We have 3x plus 2y equal to 3 to the power 5. Now bases are the same, what do? We equate the exponents. We have x plus 2y equal to 5. Let's call this equation 1. Now the second one says that 3 to the power x divided by 3 to the power 2y equal to 1 over 27. Now what can we do here? We can change this 27 to 3 to the power 3. So you have 3 to the power x divided by 3 to the power 2y, 1 over 3 to the power 3. Now a to the power negative n is the same as 1 over an. That is a to the power negative n. This is equal to 1 over an. So you have 3 to the power x divided by 3 to the power 2y equal to 3 to the power negative 3. Now we are dividing here, we can subtract the exponent. These are the same. So x minus 2y equal to 3 to the power negative 3. These are the same, we equate the exponent. So we have x minus 2y equal to negative 3. Let's call this equation 2. Let's see, where's equation 1? This is equation 1, and then this is equation 2. Looking at it, we can add the two equations. So we can say that equation 1 plus equation 2. Now x plus x, this is 2x. 2y minus 2y, that is 0. And then 5 minus 3, that is 2. Clearly, we can't find x. We can divide through by 2. So we have x to be equal to 1. You can also put x equal to 1 into any of them, let's say into equation 2. Now, x is 1, so we have 1 minus 2y equal to negative 3. We want to find y, so let this go there. So we have minus 2y equal to negative 3 minus 1. Minus 2y equal to negative 1. To find y, we divide both sides by negative 2. Y, so you have y to be equal to 2. But the question says we should find x plus y. Therefore, x plus y. What is x? X is 1. What is y? We had y to be 2. So 1 plus 2, this is equal to 3.